is a living miracle with so many connections and so many tasks being done all at once. Welcome to EazySense with scientist, author, and professor Dr. Patricia Broderick. Dr. Broderick is a medical professor in molecular, cellular, and biomedical science at the City University of New York School of Medicine and has invented, patented, and trademarked a revolutionary technology that will change the way we understand the brain. Some medical doctors have stated that the Broderick probe will change the face of science and medicine. So please welcome the host of EazySense, Dr. Patricia Broderick.
Okay, Happy New Year. Okay, how was everybody's New Year? How was everybody's Christmas? Okay, we are going to go now the whole hour again without any commercials. Isn't this wonderful? This is no commercial airtime, and it's all about this tiny little probe called the Broderick probe, named after my father. Okay? His name, by the way, was Patrick Broderick, and I am indeed Patricia Broderick. Okay, and yes, I am a medical professor at the City University of New York School of Medicine, proudly so. And Kishan Reddy, I am very proud to introduce. He is a senior at Kishan.
At the
Tell us
United
about your
Nations
school.
International School.
You bet. And your degree will be in what?
My degree will be in biology. I'll major in biology in college, and my degree will
Yeah.
be related to medicine.
Uh huh. Okay. But what's the title when you graduate from your school? You have a certain title, international degree. It's not
Uh,
just yeah, it's not just a baccalaureate. It's something more
it's like I.
fancy. I like it.
It's called the IB. So when I graduate, I'll receive the IB diploma, which is what you get at the end of the IB curriculum, which is what I'm currently in high school.
Okay, good. And so you went to school yesterday. Yeah, we
Yes.
all started school yesterday, kind of. My class doesn't start until the 27th because the city college itself starts on the 25th and the medical school starts on the 15th. And we're just winging it tonight. We're going to do the year in review, the highlights, anything that we think of that we want to go into great detail with or for or about what was interesting. Certain things come to my mind that I found more interesting than others. But we talked a lot about caffeine and a lot about cocaine and the differences and the likenesses. Uh,
Mhm.
we talked we talked about tumors, Kishan. What
Yeah.
else?
We also talked about, as you said, caffeine and cane, and we probably talked about what this whole talk show is about, which is your probe, as well as the relation to
Oh,
other, as well as relation to other technologies such as the MRI, and discuss sort of the in-depth material on how your probe can detect white matter.
oh, yes. Thank you so much. My goodness gracious, I'm almost forgetting to mention the little tiny probe because it's so small you can't even see it. Okay, we had a visitor today, and she was so impressed with it. I took it out, and she said, "Oh, put it back in, put it back in, put the top on it, put the top on it." Uh, and so, what we're going to do, we're going to license this, and we are going to sell it, and we are going to take and I won't take it out tonight because I'm super excited tonight for some reason. Uh, I think it's because I heard today that the university is interested in looking into the tumor, all the things we talked about on the tumor, finding the tumor in the white matter when it flows from the gray matter to the white matter, because we have to realize that When that tumor moves into the white matter, it's not just sliding in like next door, it's going down, down deep. And our great engineer is putting, oh, look at, he's putting up a picture of the Broderick probe, greatly oversized because we drew it so you could know. Thanks so much. This is like I love this show. This is a TED Talk personified. We are so relaxed. Uh, I just want to say that we're a talk show. And so I want to give the number 866 451 1451. And we do want manufacturers to call us. And we do want people who are entrepreneurs and interested in working with us. So not only just to talk with us, but let me say the number again, 866 451 1451. Okay, so here we are on our weekly show, the college, well, actually, we're close. Uh, the professor and the high school student on his way to college, together
Mhm.
working on this tiny probe. And of course, Kishan, you just thought of this. I almost forgot to say it. Okay, so welcome back. We're going to have another hour of uninterrupted show. And we're just going to talk about all the different things that we talked about last year and this year, just like the way all the shows do, uh, highlighting. And thanks for that picture of the probe there. It shows exactly where the carbon is and where the protein is because there's a connector part. This is the whole thing is smaller than a human hair, uh, including every part. Oh, and so what we want to do, especially in this semester, we really want people to know that our photodiode patent is issued and that anybody who knows about photodiodes, uh, and we're using the smallest one in the world. We have it patented. We have the smallest one in the world, and we're going to put it on this probe here. And so we're not going to open the brain at all. We're going to look in without opening the brain. And we have a lot on the schedule. Uh, we have a grant in, a technology grant, and there's the picture of the brain. Uh, I just want to say I want to give kudos to our director, Eddie Dunn, and to our producer, Tom Shizano, because they're giving us the opportunity to talk about this probe. And on TV, you're just going to get so much more coverage than you do when you're just passing paper around. So now we have a picture of the brain. We have a picture of the brain with the skull on. So where do we want to talk? Where do we want to go next, Kishan? Let's look at this
Um,
brain together. Yeah.
yeah. Okay. So right now, this brain, obviously, we can see all the specific um, hormones, such as first off, we have to see the specific parts, such as the hippocampus. We have what the nucleus accumbens, which is sort of the reward pathway of the brain. And in one of our most recent shows, we talked about, as we said, the caffeine and cocaine, which is basically where all of this sort of action happens, which is in the nucleus accumbens. And this image sort of shows how dopamine and how serotonin basically goes all around the brain, and how people sort of want more cocaine because of the amount of dopamine that is in the synaptic cleft when taken.
Oh, so perfect. Yeah. Um, Now, let's talk about the word psychostimulant. It seems that people get very upset when, well, I had said, I published once that caffeine is not a psychostimulant because it doesn't cause psychosis, whereas cocaine does cause psychosis. It is a psychosis induced schizophrenia, but caffeine doesn't do that. But but people got upset with me because they said I shouldn't say that caffeine is not a psychostimulant, but I write in the federal government's review of substances that cause problems. The latest one is 2013, believe it or not. This is 2023. We should be up for another one. But this is the one that's called number 5. And in there, they took caffeine off the toxic substances. And so that agrees with my thoughts. I actually don't drink coffee at all. Uh,
You know what?
and and you don't either. This is amazing. And we can stay up any number of hours and study without the caffeine at all. Uh, and we sleep fine. So it's really great. We're looking at these great pictures that our engineers are putting up. We have really cool engineers too. Really cool engineers. And I love this picture. I love how this picture comes out and how they can bring all the both of us in at once, et cetera, et cetera. And I'm remembering a lot now to look up at the camera more so than I have in the past. Uh, okay, but so anyway, we talked about cocaine causing an orgasm, and caffeine doesn't. So that, oh, look at those. Oh, here we are. I'm going to pass the microphone to you, Kishan. Look what we have here. We have a picture of the another pretty one of the probe with the blue background, and then we have the signals that are coming out of the brain. How do these signals come out of the brain? I mean,
Well,
like what does it look like? I
um,
mean, yeah. I mean, you have an x-axis and you have a y-axis, right?
yeah,
So, right. And so now, does this look like an EKG, like what you get at the doctor's office?
no,
Or does it look like an MRI? Uh, let's just, tackle it.
yeah. Not well. As you were saying, this doesn't look like an EKG that we usually get at a
Right,
doctor's office.
right,
That's because of
right.
like the usually with an EKG, you have multiple spikes like occurring at a specific at like expected amount of time on the graph.
Uh-huh,
But with these graphs, you
uh-huh,
have a very strong peak, as you can see by the first one, and
uh-huh,
even the second graph, you have a overall increasing trend
uh-huh.
in the current
Yes.
as shown
Yeah.
as seen in the second graph.
Yeah. Perfect. Perfect. What beautiful way you express all of this. I am impressed. I love it. So we have actual pictures. Okay. Whereas in EKG, you have a waveform, and then
Waveform.
there's the little blips, and then another waveform and another blip. And so everybody can see that when they go to the doctor. And when we have this licensed, whether it's licensed to the EasySense nanotechnology company or whether it's licensed to another company, uh, we're going to give people pictures so that when we talk about seeing white matter in the brain, white matter causes big problems with tumors and cancers, and it's
Mm-hmm.
the worst kind of cancers. And white matter cannot be looked at in the same way that gray matter can be looked at because white matter doesn't have very many neurons.
Yeah.
That's why, yeah. Um, if we take a disease like multiple sclerosis, that is a white matter disease because the myelin sheath is is degrading, and that's why the person's little by little cannot walk. How sad that is, and how lucky we are, really, to have healthy brains and healthy lives. Uh, the miracle of the brain and the body and the physiology, the pharmacology, the biochemistry, we still have a lot to learn. We haven't learned we've done something, but we still have a lot more to do. But it's really miraculous, isn't it? And then to see, I guess I'll bring this up right now, and then to be able to see this, see what's going on with something this small. So, what's the difference between this and the MRI?
Well, basically, the probe is able to see white matter to a greater extent than the MRI.
Mm,
Uh,
it is
yeah,
actually. It does actually.
yeah,
Yeah. It gives a picture. If the engineer wants great engineers, I'm not going to say engineer, I'm going to say great engineers, puts the picture of those waveforms. Yeah, our pictures come out as waveforms. See, like that. Very pretty waveforms. So
yeah.
it doesn't come out as a little round blip and then a spike and then a round blip and then a spike. And then with the MRI, the white matter is seen as a divot. It's like it's just a little mark that there's something wrong. But we actually give people the picture, and no matter where it is, like even no matter how deep it is, we can see it.
Hmm.
So we can't wait to get to the marketplace, and we are going to need. Uh, I'm going to give the number again. We are going to need partners. We are going to need entrepreneurs. We are going to need people with us to get this done. And I'm going to give the number again, 866-451-1451. That's the number to this show. So you can ask us any questions about anything that we've talked about, or any questions about the probe, or where we're going, or why we do this. I wonder why we do this. We could be just, sitting watching movie after movie after movie. Why are we so interested in science and medicine?
Well, I think it has to do with the medical field is always evolving. New things are being discovered every day to get more to get more efficiency within the medical field. As you said, your probe it's able to identify these tumors and help with these neurodegenerative diseases way better than the MRI ever could, as well as detect tumors in the brain. And I really think just like the because with like you could say go back like 50 years ago, you would never imagine how much medicine has evolved over a very short amount of time.
Uh huh. Oh, a miraculous amount. Yeah.
Yeah,
And very many people willing to give their lives to study and study and study and study rather than just take drugs.
yeah.
Oh,
All
yeah.
in the matter is helping people and just like getting better. And it's always
Yeah.
about just caring about the patient as well.
That's exactly right. It's all about better patient care, better bedside care,
Hmm.
smaller equipment so that it's not bulky and in the way, and it doesn't cause, oh, by the way, it doesn't cause bacterial formation. It doesn't cause scarring. There's no scarring. And who said that was the pathologist. I don't know the pathologist. And he wrote, Broderick probe does not cause any scarring. The epilepsy, the epilepsy electrode, he wrote, I don't know his name, of course, because it's all double blind or triple blind. And he wrote, the epilepsy electrode does cause scarring, but the
Yeah,
Broderick probe does not cause scarring. So that's published. And it doesn't cause bacterial infection either. So it's so small and it's so amazing. And it's going to be so economical, and there's not going to be a tunnel that you have to go through. And when, like we do in the MRI, I never once had an MRI. Did you have an MRI?
Never. I've never had an
Yeah,
MRI.
see, we don't drink coffee and we didn't have any MRIs either. That's good. But now we get a better picture of what's going on with our studies. We get pretty pictures. And each neurochemical is at a different point so that you can tell which neurochemical is dopamine, which neurochemical is serotonin, because it's obvious. Whatever point at which it comes out on this X and Y axis tells you what you have. So it's really precise, really precise. And uh, let's just go on with your thoughts for a minute, because something came to my mind a minute ago about how these people were selling cocaine with fentanyl in it, and then they brought it to they hand deliver cocaine with fentanyl in it. It's unbelievable. So
Yeah.
I think that was one of the highlights. Like, not that it's a toxic highlight and it's not so much fun, but I was amazed at that. I could not believe that we're working so hard to get a company called EasySense on the ground and running, and they actually have real companies. But of course, it can't be a really valid company.
Yeah.
It's real. It's got to be an underground, sneaky, against the law company, right?
Yeah.
Yeah.
And
Uh,
I don't
yeah.
think they go around advertising their company. Like, I don't
Right.
think
I don't think that they have it on the side of their truck, you know, like cocaine plus fentanyl. Get it here. Right. They can't do that. They can't do that. So,
they.
um, yeah. And when we think about nicotine is a plant like alkaloid, plant like caffeine is, like cocaine is. They're all alkaloid plants, and they all act to change the neurotransmitters in the brain. Look at I'm going to say our great engineer again. He has up here a picture. Actually, this came from the paper you wrote. This is fabulous. And you tell us about it. I'll just relax.
So basically, this shows us the presynaptic and postsynaptic membranes, as well as the synaptic cleft. So this is a primary example of why people get addicted to cocaine. So basically, when the dopamine is in the synaptic cleft, cocaine doesn't allow it to be reabsorbed back into the presynaptic cleft, which makes it and then yeah, which makes the dopamine build up within the synaptic cleft, making people want to have more of it as it gives them more pleasure. This connects back to the nucleus accumbens as I was describing before. And basically, this cocaine is really bad for you because if you continuously have it, more dopamine will be concentrated in the synaptic cleft, which can cause, like as she said, which is really bad for your health. And I would, and sort of going back to the delivering of cocaine with fentanyl. I don't know how
Yeah,
anyone
yeah,
could. I don't know how they're getting away with it. Honestly, very
yeah,
easily.
yeah.
It's honestly
Yes.
really
Yeah.
bad because like of all the horrible things that cocaine has done.
Oh, yes, because it's coming to my mind when we did this show that there were three people. There was a man in his 40s found dead in the hotel, and then a woman 38, another woman 23. They all took this particular delivery of cocaine with fentanyl in it. Yeah, and you're right. They do get away with it very easily. And tell us how you feel about that.
I feel bad. I feel bad for the victims who had to suffer through this. Who had to suffer through the through them just taking the amount of cocaine that they did. and they paid the price for not knowing the real science behind why cocaine is so bad for you. And just first off, I don't. First off, they just thought they was ordering cocaine, but they didn't know that. But they did not know that there was fentanyl in it, which is even worse. Because
Ah,
as we
uh-huh.
know that three of them have died because of this horrific event.
Exactly. Uh, yes, so well, eloquently put. Right. So if they didn't take the cocaine to begin with, they would have been much better off than the fentanyl on top of it, and
Exactly.
and sneakily done so that the people didn't know, so their loved ones didn't know, and their
Hmm.
loved ones were shocked that they had somebody dead. Uh, just horrendous. I wish that it really weren't so easy to do those evil things,
Hmm.
because we work and work and work and work and pray and pray and pray that our work will be accepted and it will be good, and every single thing we write down and every single publication we're trying to do better and better, and to just kill people for
Yeah.
what? Uh, for what? And what this is like more of a philosophical question, like what kind of neurons are in the brain of somebody who does that. I mean, I don't know the answer. Maybe we're just doing, we're relaxing tonight. Kishan was telling me when he went back to school yesterday, it was an easy day. That's what I love about his school, because like it's stringent, you learn a lot, it's strict, but then yet when the first day back and it's in the 60s and and it's January, you go back in a more relaxed way. You're
Yeah.
not, yes, like you're not being taught by I don't know how to say it, techniques that are too rigid.
Yeah.
Because when we're taught by techniques that are too rigid, we can't remember them. We can't remember the information as well as when we're relaxed. Like here we are, we're talking about nucleus accumbens and reward, etc. And we do need reward. Every one of us needs reward. It's wonderful to have brain reward. It's just the bad part is the people who try to uh, kill people. Uh, I just it just takes my breath away. But here, what we're doing now, uh, this hour goes so quickly, and we're just relaxing so people can turn on the TV now, and see that here we have a professor and we have a high school student who delve into the brain at such depths that we're willing to give up our time to study more and invent more, and bring more technologies to people and to animals too. Yes, I got the animals in there, because I just love the animals. And I want everybody to be kind to them when they work with them. Uh, let's see what else. This is a relaxing night. We're coming back January 4th. I think it was 67 degrees today. I think so.
Yeah.
Something. It
It
was
was like,
about that.
sorry.
Yeah. And then we had 20-degree weather. And then
Hmm.
we had 60-degree weather. Uh, I don't mind. I don't mind at all. I mean, hopefully. Oh, well, Buffalo. I felt very bad for Buffalo because they had so much they could not get out of that ice and that snow while we
Yeah.
were. Yeah, I did feel bad for them. I really did. Uh, and here we are in New York. Uh, I'd like this kind of new weather all year round. 60 degrees in the winter. This is, yeah, just beautiful. Now, let's think I'm just going to hand the microphone over to you while I take a look at the camera again. I really have to hone in on my way of doing this show and looking at the camera the right way. Because you're supposed to be talking and you're supposed to be looking at that camera because your brain tends to look at the person next to you. Uh, oh, so the Melissa Billy Clark show, I did that show at some point in November. I remember it's November 17th. I just received a text, there was an email from her that the show is coming out soon and they'll let us see it before it goes to press. But not only that, they are going to use our show as a promotion for
Oh,
yeah, I just got this on, it was actually on Thursday that email came in, and they're using our show as a promotion. In other words, yes, the show is making a difference, but because we actually have a product and we're actually making something uh, that is going to revolutionize an industry, uh, they want to use ours as a promotional one, like this is the kind of thing we want you to bring to us, like not just that you did something, you wrote one book or something like that, that's just something to be admired. uh, but they don't, like they were so impressed with a product, with actually building something, and then building something so small that they're making our show the promotion. In other words, please give us something like this.
yeah.
Don't give us ordinary things. Give us extraordinary things. So that was thrilling. That just came into my mind. I had forgotten about it for a minute. But they're looking for inventors, they're looking for innovators. And actually, that's who we're looking for. 866-451-1451. We're looking too for, we're looking for people to partner with us, uh, who would actually be awarded some shares in the company. We do have shares. uh, we are just beginning. We're not trying to make believe that uh, we are a big oil company, with several subsidiaries. We are a baby company with a tiny little probe, but that it is worth billions of dollars. Uh,
Yeah.
the value is billions. Uh, Once we get it from the laboratory to the clinic. Okay, so we did go into the clinic and we actually put the probe. Uh, Maybe the engineers, there's a couple of more pictures of brains. If you could put some of those brains up, because we showed one week where uh, we showed what the epilepsy brain looks like when it's open. But if we can't find that, you're going to find it as we talk. But what struck you about that brain with the skull off? Was there something that struck you in a special way?
Uh, well, the first time looking at it, it really shocked me just because like I really didn't know how like the human brain looked from that point of view,
Oh,
and
yeah.
what really caught my eye was the central nerve that went right through the middle of it,
Oh,
and it was like really just, it was really amazing just seeing a brain like that because all my past experiences of learning about the brain, I've only seen like drawn diagrams or like labeled like, oh, this is like the hippocampus and
oh,
like all
yes,
that
yes,
stuff, but seeing it
yeah.
in real life is just like
Mm.
astonishing.
Yes, actually pulsing and living,
Yeah.
with the blood of life moving around. It is phenomenal, just phenomenal. Uh, Now we ran the gamut of pharmacology, biochemistry. Oh, you know what? This probe here, it runs the gamut of neural engineering, bioengineering, biomedical engineering. Uh, what else? Neurotechnology, nanotechnology, nanobiotechnology. Yeah, physics, physics. Uh, all of those, and Cottrell equations, Faraday equations, etc. So whatever, you know, there's something for everybody. it
Mhm.
crosses it crosses all the disciplines, and this can be used in so many different disciplines. So yes, we have been in the operating room of Tisch Hospital at NYU, uh, Langone Center, actually taking this and lightly taking this Broderick probe. I'll say again, named after my father. And then very lightly, 2 microns, 1 micron, just barely touching the brain. And we can see exact first time that anybody has ever seen neurochemistry in the brain of the epilepsy patient.
Wow.
Nobody ever thought about neurochemistry. I'm thinking about where I learned one day that Hans Berger in 19, I think it was 1942, he did the first electrophysiology in the epilepsy brain. In other words, he saw the neuron firing in the brain. So that means he saw an action potential, and he saw the neuron. He didn't see what the neuron was,
Mhm.
or which one it was, or actually what it was doing. But when it fired and caused the seizure,
Mhm.
he saw that.
Wow.
And that was 1942. And so this is 2023. Okay. Look at the leaps we've made.
Yeah.
Because, oh yeah, because even if you think about deep brain stimulation, uh, that's what we were talking about this morning, my patent attorney and I. He is a very interesting person. I don't see, I'm so involved in being a scientist, I cannot understand how anybody could not be, because every conversation is so interesting and so pulsating, and a million ideas come from one sentence. It's just fun. It's just fun to have a brain to be able to delve into things that have never been delved into before. It's just plain fun. So yes, we have been in the operating room. Dr. Werner Doyle was the surgeon, and on that day he had said, "This day will be remembered in all for all of eternity." I'll never forget that. Yeah. I happen to have been in a terrible accident right after that. Uh, and did I mention that terrible accident to you? This
Mm.
was in Boston. I don't think I'll say it right now.
Yeah.
It was in Boston, and we were talking about the work we did in the epilepsy patient. Yeah, and so it was actually Christmas time. It was not freezing cold. It was only in the 40s or 30s. It really wasn't freezing cold, not like this past Christmas, etc. Uh, but we were in a parking lot. I don't know how much I can say about this, but there was a curb there that wasn't there when we went into the Heinz Convention Center. There was a curb there that wasn't there when we came out. In other words, we were at a different entrance or exit. However, we didn't see it, and there was no yellow sign, and there were no lights. And so I walked off the curb and I walked in the air because I'm very light on my feet. I'm a dancer. and I was looking forward to giving a talk at Insulet Company to use the probe for diabetes. I didn't get a chance to mention that to you. I couldn't. They were sending a car for me, etc. And it was just such a festive time. And because the curb was there, and I walked off the curb and I walked in the air about 6 feet. The colleague who was with me is Don Odom, one of my publishers, and he watched me walk in the air 6 to 8 feet. I ended up flat down on the cement, smashed on the
Oh,
cement. Yeah, far, far away from where we started out. It took him a long time to find me. I was smashed underneath the cars, and I lived through that. Isn't that something?
yeah,
Um,
it's awful.
yeah, and how resilient the brain is, and how resilient the body is. Uh,
Yeah,
yeah. So I hadn't. I don't think I had mentioned that, right? I didn't.
no,
At least I didn't mention it in detail because we don't go around talking about these things like this because I'm just fine now. Uh, and I lost very little time, very little university time, because I had to get better and get back. Uh, so, this study of the brain that we do, uh, the brain is certainly worth studying.
yeah.
Uh, yeah, because it desires to live. It desires to live. Um, what I'm thinking of now is what happened that particular day, that particular night. Uh, can you imagine practically every bone in your body broken? And here we are, and that night happened to be a very important night for this probe being in the epilepsy patient.
Wow.
Now, yeah, how strange life is sometimes. Yeah. So we really didn't cancel anything. There were people who wanted to come see the probe. They came. And I had the hospital gown on when I met with them. Yeah, I didn't cancel anything. Uh, and so I'm going to say this number once more because we are resilient and we really do want to get this on the road. The number, it's a talk show anyway, so anybody who wants to pop in and say something else, say something about caffeine, etc. The number is 866-451-1451. We did have my medical student, no, it was my City College student, Luca Bonadonna, with us, and he told us that he drank coffee all the time. Oh yes, and we talked about cereal bars,
Hmm.
cereal bars with caffeine in them and cereal bars without caffeine in them. Uh, that you did a lot on that. What did you tell us about that?
I said that. Well, I personally eat like those caffeine bars usually like when I need like some energy. And what we basically found out is that most of these bars do contain small amounts of caffeine in them. And as you said,
Uh-huh.
caffeine without caffeine, like we need caffeine to survive. I remember you saying, and yeah, honestly, there's just so much to learn about caffeine. And one thing that most people usually mistake is coffee is different than caffeine.
Oh,
It's
thank you.
a
Yeah.
mistake.
Keep on going. Yeah. Yeah.
Yeah.
I'm sorry. I got excited. I interrupted. Excuse me. Keep on going.
Oh no, it's okay. Don't worry.
Yeah. Yeah, because caffeine and coffee are two different things. Yeah. So
Yeah.
continue with what you were going to say.
Yeah, so what I was basically gonna say is that coffee contains caffeine, but
Uh-huh.
so I remember you giving um a specific quote. I remember you saying that. So, caffeine is a rectangle, while coffee is just a square. I
Oh,
remember you.
yes. Yes. Oh, yeah,
Yeah,
like that. Yeah, there was a student in my lab, and she's from Rochester. Uh, and she was very interested in studying the caffeine. And when she wrote the editorial, she wrote this editorial entitled Stop Saying Coffee. In other words, stop saying coffee is the same as caffeine. Coffee is to a rectangle as caffeine is to a square.
yeah,
They're two different things. Yeah, and you're remembering the titles of those editorials. Great. Uh, yeah, I served as the chief, the editor in chief of the Journal of Caffeine Research, and then everybody thinks caffeine and coffee are the same thing, and I never had a cup of coffee, so people got a kick out of that. But you're right; you're bringing up an important point. Coffee and caffeine are not the same thing, and I also eat cereal bars every single day. Uh, and I enjoy them tremendously. And there is caffeine in them, and you can't taste the caffeine, you can't see the caffeine. Um, and they're fiber bars, so you have the fiber and you do have the caffeine. As you say, there are some without. Oh, you did a very detailed analysis of this. You had several different kinds, and then you had that was wonderful what you did. Then the night also that you talked about tumors in white matter and gray matter, and you described the white matter and the gray matter before describing all of the pictures that came from the brain that that in the studies that we did from epilepsy patients. We actually have 22 publications in epilepsy. We have 22 or more publications in epilepsy. Yeah. So the probe can. What else can the probe study? Tumors in epilepsy patients, um, drug, brain reward. Uh, oh, when there's too much reward. When there's fentanyl inside the cocaine. Oh, when we were talking right before the show, I mentioned I do. We did do studies on fentanyl, and it broke the machine.
yeah.
Yes, and I have to find the exact data because we should publish it. Uh, yep, that's part. Yeah, we have an exciting year ahead. 2023, I think, is going to be very exciting for us in particular, for you and for me. We have a couple of things on the horizon, and I know it's going to be exciting for so many of our viewers, so many who watch us every single Wednesday night and see the beauty of being a scholar. Actually, the beauty of being a scholar. It takes you away from the drug world altogether. It
Mm.
takes you, yeah.
I remember
Uh,
you saying to your students you said a quote to stay away from the drugs, and I'm forgetting the quote, but um, stay off, like keep away from the. It was something to do with studying. It was like keep away from the drugs, and it was
I'm remembering. Yeah, yeah, yeah. My advice. Yeah. Oh yes. Instead of I stay away from. Well, the dealer now is all over the place, but
yeah,
uh, now that we know they deliver, that's ludicrous. But now that we know they deliver, stay away from the 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 dealer. Stay away from the dealer because you know you're going to get more pleasure out of caffeine. You're going to get more pleasure out of and actually out of a cup of coffee if you drink coffee. That I mean, my whole family drinks coffee. I'm the only one. Are you the only one in your family who doesn't drink the coffee?
Well, my my sister usually only drinks coffee the most in my family. My dad
Oh,
actually drinks tea instead than
oh,
coffee. And yeah,
okay.
my mom, I don't. Yeah, my mom also drinks coffee as well. So we have a Keurig at home. So she'll sometimes make the coffee in like the little Keurig.
Oh, how cool. Yeah, and I will drink a cup of tea. I enjoy a cup of tea. And
Yeah,
what I love about tea is that there's theophylline in it, and theophylline opens up the airways. So that's actually why, you know how sometimes we don't feel well and we look
yeah,
for a cup of tea. Yeah. See, the coffee doesn't have any theophylline in it. Theophylline is just a big word, but it actually opens up all the airways. And so I think that's why sometimes that we desire a cup of tea when we don't feel well because of the theophylline. Next week we'll have theophylline on a screen. I think that we are going. I can't believe this, but I think that we're going to say goodnight in a couple of minutes. Can in just about 5 minutes. I'm taking a look at my notes from my engineer. Uh, okay, good. We are going to stop and say goodnight. We had another show of uninterrupted, intellectual, and fun conversation between two scholars.
yes,
Yes.
yeah. It was a really fun time. It was a really fun time.
Yeah. Yes. And so we're going to say what we always say, uh, good night, good morning, good afternoon, all over the world in this beautiful 2023. Uh, 2023 is for my godchild, like this because I sent this out to her and she loved it, so I'll say it. 2023 is for us to behold. We are the beholders. Let's step into 2023 and enjoy every single second.
Yeah.
Okay. Uh-huh. And so that is a wrap. We will see you next week, Wednesday at 8 p.m. It will be our pleasure and yours. Kishin, good night.
Good night. It was a very fun time being with you today, Dr. Broderick, and I can't wait until next week comes.
Ah.
You've been listening to Easy Sense with your host, Dr. Patricia Broderick. Tune in each week as Dr. Broderick talks about her new breakthrough in science and technology. Here on Dr. Broderick's Easy Sense.